guys, welcome to today's mini lecture. Earlier this week in a mini lecture we talked about the difference between an atom, an ion, and an isotope. Well, in today's mini lecture we're going to focus on one aspect of that, which is the nucleic expression. The nucleic expression is literally a set of symbols and numbers that allows you to determine the number of protons, neutrons, and electrons, as well as the overall charge. So I'm going to begin by doing an example of a nucleic expression of magnesium. So over here to my right, you can see that I've set up a periodic table. And if I look on the periodic table, magnesium is way over here, and its symbol is Mg. So if I'm going to do the nucleic expression, then I would write Mg, and that's its symbol. The next thing I want to do is I want to look at some information that's given on the periodic table. The first number is the one in the upper right-hand corner, and that is the atomic number. And the atomic number of magnesium is 12. The atomic number is also going to determine the number of protons. We also have another number, and that number is the mass number. And for magnesium, you can see that the mass number is 24. So the atomic number is written in the lower left, mass number in the upper left. Now, if there was a charge present, that charge would be written right here. But since there's no charge, we don't put a positive or a negative or any of that. We just leave it like this. But what we can do is do and I like to call it the pin number. And the pin number is nothing more than protons, electrons, and neutrons. So our protons is going to be equal to the atomic number, so it's 12. Now, since there is no charge, this is where it gets kind of tricky sometimes. Since there's no charge, then the number of protons and the number of electrons would be the same. If there was a charge, there would be a difference in the numbers because one proton has one positive charge and one electron has one negative charge. So if you have the same number, they will cancel the charge out and you'll get an overall neutral atom. And that's exactly what we have here. So I have 12 electrons. The number of neutrons is based upon its mass. We know that the electrons have little to no mass. So all the mass of an atom is going to be composed of the protons plus the neutrons. Well, if I know the protons and I know what the overall mass is, all I have to do is subtract those two and it will give me the number of neutrons. And in this case, it is 12. Now, guys, we don't always want to just automatically assume that they're the same because they're only the same, like this one's 12, 12, and 12, with your lower, less mass elements. So now what I can do is I can come across and fill this chart in. I got a Mg for magnesium. Atomic number is 12. The mass number is 24. Number of protons is 12. Electrons is 12. And neutrons is 12. So I just completed the first one. So the next example is going to be looking at a symbol of S. And we know from looking at the periodic table that, and I'm going to move the camera over just a little bit. There we go. S is on this side, and that is going to be sulfur. So I'm going to write its symbol down. Then I'm going to do its full nucleic expression. The key to this is you don't want to get in the habit of trying to fill the chart in before you have all the information. If you do that, you'll end up having some sort of a little mistake in it. So in this one, we have an atomic number of 16 and a mass number of 32. So the pin number for sulfur is going to be 16. There's no charge, so electrons are 16. Neutrons is 32 minus 16, and again, it's 16, 16, and 16. So I come over to my chart, my table, and I go, this one is sulfur, and then it's got 16, mass number of 32, proton number 16, 16, and 16. Again, it is the same. It is the same numbers, but like I said, that doesn't happen as often as it's appearing up here. So let's go ahead and do the next one. And this one, I gave you the atomic number. Well, you got to remember that we talked about the protons determines the element. So the number of protons determine the element. The atomic number determines the number of protons. So there is 50 protons. So I can look over here at my periodic table. I can find number 50. And number 50 is right here. Its symbol is Sn, and that is called 10. So I'm going to say Sn 50. Now I'm going to have to look at my periodic table. It says 118.7, so that's going to round up to 119. This time, when I do the pin number, I end up with protons 50. In today's class, we're not going to deal with any charges, so the protons and electrons are always going to be equal. That way they balance each other out. The neutrons is going to be 119 minus 50, which is a 9 and a 6. So you can clearly see that this is much, much different from the other ones. So I'm going to put 10, T-I-N, it's S-N, its atomic mass or mass number is 119. Then protons is 50, electrons is 50, and my neutrons, run out of range here, is 69. All right, so if you notice, you can see that we have a couple of things going on here. We have, sometimes I'm giving you the actual element's name. Sometimes I give you the element symbol. Sometimes I give you the atomic number. But it doesn't matter because once you have those, you can go through and figure out everything else. Excuse me. So what I would like to do is just give you a little recap on nucleic expression. Nucleic expression has a symbol, then it has the atomic mass or mass number on the top, atomic number, which is your protons at the bottom left, and then this area right here is reserved for the charge. And in today's class, none of the elements or none of the examples that we were doing had a charge. All right, I hope that this little mini lecture allows you to go through and answer your subatomic worksheet. Just make sure that you do this. You draw out your nuclear expression. It's not that I need, or nucleic expression, it's not that I need to do that to check it. It's just that you don't make little common mistakes nearly as often once you have it all the way written out. All right, thank you.